Okay, we're on the 6.8 set, and we're going to use our new trigonometric ratios for right triangles to get some side ratios here. So I'm going to write katoa across the top here so that we can reference this as we're going. So the sine, the s function, is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So here it says we want to do first the cosine, the sine, and the tangent of A. What that means is you're going to be pretending to stand here at A as your reference angle. Which side is opposite of A? Which side is adjacent to A? And which side is the hypotenuse? Well, that's always the hypotenuse. The longest side across from the right angle. Okay, so the cosine of A would be 4 over 8.06. And I actually want you to grab a calculator, divide these fractions, and get me the decimals, okay? The sine, trying to make this fit. The sine is going to be the opposite, 7 over the hypotenuse, 8.06. And then the tangent is the opposite over the adjacent, 7/4. So go ahead and put those into a calculator for me and get the approximation for each. Okay, now we're going to be switching our reference angle to reference B. So this time if I'm standing here, then my opposite is going to be the 4, and my adjacent is going to be the 7. And the hypotenuse is always the hypotenuse. So for the cosine, we need the adjacent over the hypotenuse, 7 over 8.06. Sine, opposite over hypotenuse. And tangent, 4 over 7, opposite over adjacent. So what we're going to start to notice here, oh, and by the way, go get me those decimals. What we're going to start to notice here, cosine of A came out the same as the sine of the other angle, the B. Sine of A came out the same as the cosine of the other angle B. And tangent of one versus the other was the reciprocal. Interesting. All right, let's go do the same thing. Now, pause the video. Try to do the next one on your own, please. First, we're going to be standing at reference angle A. That makes this my opposite, and this my adjacent, and this is my hypotenuse. Cosine of A is going to be 8.5, the adjacent over the hypotenuse. Get me that decimal. Sine of A is going to be opposite over hypotenuse. And tangent of A is opposite over adjacent. Get me all three of those decimals. Now we're going to switch reference angles. Now I'm standing at B. So this is my opposite, and this is my adjacent. Cosine of B, adjacent over hypotenuse. Sine of B, opposite over hypotenuse. Tangent of B, opposite over adjacent. Get me the decimals for all three of those, please. And we notice again that the cosine of A is equal to the sine of B. Sine of A is equal to the cosine of B. And then there's our reciprocals. All right, to start, we're going to be standing at reference angle A. So this is going to be my opposite. This is my adjacent. And as always, here's my hypotenuse. Uh-oh, the hypotenuse doesn't have another side. So we have to do a little math here. 3 squared plus 3 squared equals that hypotenuse squared. So that's 18. So my hypotenuse is root 18, or 3 root 2. Now why is it 3 root 2? Because 9 times 2 square root of 9 is just 3. The 2 stays under, the 3 comes out. Okay, so we have a 3 root 2 up there. Here comes cosine of A, adjacent over hypotenuse. Sine of A, opposite over hypotenuse. Tangent of A, opposite over adjacent. We're switching reference angle now. Up here, cosine of B, adjacent over hypotenuse. Sine of B, opposite over hypotenuse. Tangent of B, opposite over adjacent. Look at the relationship here, you guys, on this triangle. Isn't that weird? Now, the reason this one came out so weird, do you see how this is both 3 and 3? This is called an isosceles right triangle. So it's not just special, it's really special. It's got the same 2 side lengths. We'll learn more about those later. Okay, last one. Pause the video, try it on your own. Uh-oh, we're missing an adjacent again. Okay, cosine of A is equal to adjacent over hypotenuse. Sine of A is equal to opposite over hypotenuse. Tangent of A is equal to opposite over adjacent. Cosine of B, so we're switching reference angles now. Now my opposite is 8, and my adjacent is 6. My hypotenuse is still 10. So cosine of B is adjacent over hypotenuse. Sine of B is opposite over adjacent. Opposite over hypotenuse. And tangent of B is opposite over adjacent. So again, we notice and there's our reciprocals. Okay, are you starting to get better at which trig function to use, sine, cosine, or tangent? Or is it still confusing to you? Now, by the way, I asked you to get all the decimals for these. Double check yourself right now to see how did you do on all these decimals. Okay, good job today. This is your classwork. Turn this in now. You're able to start your homework.